My name is Karsten Silz, and I want to make your life better today by answering one question, which is, can we build mobile, web, and desktop front ends with Flutter and one Codebase? The answer is yes, we can, but we shouldn't, and I'll tell you why. I can only recommend Flutter on mobile, not on web and desktop. Since we are Java developers, we also need to talk about Java frameworks, and their thumbs down as well for both JSF and JavaFX, and again, I'll tell you why. So here's the agenda. First, why do we need cross-platform front ends and how can we actually build them? Then the main part of the talk, how does Flutter work? Then briefly my experiences with Flutter, and then finally the question, when should you use which framework? Okay, so who made me the expert? Well, in a sense I did, because I put a Flutter app into the UK app stores, iOS and Android. But many people did that. But I'm also a InfoQ Java news reporter, and I helped organize the Java and front-end tracks at KubeCon London, happened last month, and KubeCon Plus happening this week and next week. I've been a Java developer for 23 years, still write Java code, hopefully pretty much every day, unless I'm at conferences. And even though I use Flutter, Angular, and Spring Boot in my projects, I'm not associated with them. I'm not a developer advocate. I don't sell you a book or training courses or something here. I just want to share my knowledge. And you get bonus points if you know what this on my t-shirt means. You can tell me afterwards. Okay, so slides and more, you can find them at this QR code and at this URL. The slides are going to have more words on it. My slides don't have a whole lot. So you can take a screenshot here. You can scan the QR code. I'm going to show this again at the very end of my talk. So I'll be moving on in, well, let me see when the phones are down. And now, again, I'm going to be showing this again at the very end. And hopefully it's even in the talk page on the conference website, the link. Okay, so why do we need cross-platform frameworks? Well, because our users are multi-platform. 30 years ago, when I started in this industry, making money writing software, you just needed a Windows application. Well, now we've got Mac and Linux, popular with developers, and then mobile happened, right? So now if you want to write with the native SDKs, that's like at most 5 different applications, different teams, too expensive. Nobody can find developers these days, let alone trying to staff 2 or 3 teams that pretty much do the same thing. So really, what we want to have is one framework and one language. Well, and we call that cross-platform. So cross-platform, we do that because it's cheaper and it's good enough. What do I mean with good enough? It's good enough for the kind of business and consumer applications that we Java developer usually build. This is not about games. They've got their own set of frameworks. It's just regular applications. So that's why we need cross-platform. It's cheaper and it's good enough. Okay, now that we know why we want to do that, how can we actually do that? Okay, the answer here is, of course, the web, right? We want to build stuff with web technologies, because it's the biggest software ecosystem we ever had, right? You reach like 6 million devices, 7 million devices. There's a ton of developers. It's a bit hard to learn, lots of stuff to get into, tools and HTML and CMS and, NPM and Node and Webpack and stuff. But, there's established frameworks. We've got React, Angular, Vue. They're very popular. You can find on my talk page why they are popular and proof that they are popular. So here we come to Jakarta server faces, as it's called now, which is the standard Java web front-end library, building web pages. Why is there a thumbs down? Well, first of all, we can't build single-page application, right? React, Angular, Vue build these applications, one page, and then they load stuff, pretty slick, not reloading the whole page. Can't do that with Jakarta server faces. It's also very unpopular, and you find proof on my talk page. And finally, it hasn't seen new features in 5 years. There is new stuff coming out mid this year, but 5 years is a long time. Angular ships probably like 2 releases a year. So there would be 10 releases of Angular since the last time Jakarta saw any changes. Jakarta server faces. Okay, so now if you apply that to our stack, we've got HTML and CSS as the UI toolkit, and then JavaScript and TypeScript as the language. So are we done there yet? Of course not, because We still have 46 minutes left, right? So we have issues on mobile. What kind of issues when we try to run a web page on mobile? The first one is we run into hard restrictions. You don't have push notifications in Safari on iOS. In all browsers, you typically have about 50 megabyte you can store locally, not a whole lot. And you may not have access to all native features. So this is stuff that you can't get around. The other thing is it's easier to harness the power of mobile devices with a native app. What do I mean with that? Well, we can edit videos on our phones, right? TikTok here, good example. We can edit videos, right? We can play Fortnite. Fortnite is a multiplayer online game, so they've got a lot of power there, right? So if you think about it, you've got gigabytes of storage that you've got there. As an application, you can put a database on there. Have a NoSQL or SQL database running there. You've got CPU power that kind of rivals, a desktop PC from 5 years ago. And you can talk to backends. You can make JSON calls. You can make gRPC calls. Excuse me. So really, when you see these kind of mobile applications, you should rather think desktop applications and not web applications. Okay, so that's about mobile power. The mobile power is easier to harness from a native application. And finally, the third reason why we have issues on mobile is native UI. We want to have a native look and feel. Why do we care about that? Let me give you an example of a banking app. Everybody loves to hate their banking app, so do I. Here's one from Germany. I am German, that's why I have to use that. For years, they shipped this web application here, and now they start to migrate to a native one. So what's the difference? What is so bad about the native one? Well, the first thing is, in order to do anything on the web application, you have to reach up there to that one place where as a right-handed one-hand phone user, you can't get there, right? You have to click that hamburger menu, and it's always 2 tabs. Tap the menu, tap the functionality. On the native app, you've got the nav bar at the bottom. So you see the most used functionality with 1 tap, and it's easier to reach, and everybody knows where to push that button because, a lot of native applications use these nav bars. And then you see on the web app, we've got this little twisties. My mom is 80. She probably wouldn't know that she can actually tap these things. There is stuff there, but it's not really obvious. Whereas if you look at the native app on the right-hand side, those cards, they're pretty big. They look like you can actually tap them. And so subjectively, I also think the web application isn't as nice. The mobile app looks nicer. So native look and feel. Why? Because it's easier to use. The app looks and works like all the other apps, and it also looks nicer. Google agrees with me because they're going to change all the apps in Google Maps, Google Mail, and all the other stuff. Going to change them from the Material UI that they've had so far to iOS UI elements. And here's what the manager from Google said. So what Google says is really only with a native look and feel, your app looks great on iOS. So now if we do this, we actually have 2 different cross-platform stacks, right? Because we keep our web stuff for the PC, and then we put, something on mobile, something different. Now, I've been talking about native for a while now. That's actually 3 different things in my mind and in the context of this presentation. The first thing is the application runs natively. It's in the App Store. It's an icon. It's not a web page. The second thing is look and feel. We've talked about that. And the third thing is that we want to have access to native functionality. So those 3 things, running natively, native look and feel, and access to native functionality. That's what I call native. If you use that, what kind of cross-platform frameworks are out there? The answer is a ton. So, having one application for both iOS and Android is such an alluring value proposition. There's a ton of frameworks. You can find some more on my talk page. I'm just going to be talking about 4. And my filter is open source and Java-like. Okay, first one Flutter from Google. The next one is React Native from Meta/Facebook. Then we've got Xamarin from Microsoft, which is currently being rewritten and it's will be called .NET MAUI. MAUI stands for Multi-Application UI, and it is an island in Hawaii. And finally, we've got JavaFX. Used to be part of Java until Java 11. Now it's an open source project sponsored by a company called Gluon. So, which of these is popular? Why do we actually care about popularity? I think for 4 reasons. If you have a popular framework, it's easier to use because there's more tutorials, more trainings, more videos, more books, more questions on Stack Overflow. It's also easier to convince your teammates and your boss of a popular technology. Talk about that in a second. And I think popularity can make a difference in two cases. If you've got a bunch of candidates and they all kind of score the same, you can say, hey, let's use the most popular one. On the other hand, if something is really unpopular, you probably want to stay away from it. So first data point is how often technology is mentioned in job ads. Indeed.com is the biggest job portal in the world, and I count technologies, the mentions in job ads against the 62 countries that this operates. So that's about 90% of the world gross national product. So why do we care about how often is something mentioned in job ads? Well, if you go to your team and you say, hey, we want to build, let's say, a Flutter project, then they're immediately going to ask your teammates, can I actually find a job with that technology? They're going to go to a job portal and see, how many jobs are out there for this particular technology. And your boss is worried, can I find developers? So he's going to do the same, going to the job portal, typing that stuff in. And if there are no job ads out there, he says, well, wait a minute, there must be something wrong because nobody's looking for developers. So we should probably stay away from that. So let's look at UK numbers. Going back to August of last year, monthly data. So a year ago, React Native was mentioned 722 times. Now it's 817, okay? Slightly up. There is a percentage line. What's that? Well, I used Flutter as the baseline. So Flutter at 100%, going from 183 to 236, so a little bit up. Xamarin was number 2 back in August, and now it's number 3. Kind of swap places with Flutter. And then at the bottom, we have JavaFX going from 10 to 19, yay, JavaFX, but still, 19 versus, 236 for Flutter, for instance. Okay, so takeaway, if you compare versus Flutter, we saw that React Native shrunk a little bit, 52%. That's still way ahead. And JavaFX actually gained a little bit, but, from a very low level. Now let's look at global numbers. Again, React Native from 19,000 to 25,000, but you see 248. So globally, React Native isn't as far away from Flutter as it is in the UK. Flutter, increasing as well. The Xamarin globally never was ahead of Flutter, and now it actually, decreased slightly. And JavaFX, the first two numbers I think are bogus in my counting, at 6%, so kind of the same as in the UK. So again, versus Flutter, we see globally React Native actually pulls away. Now, the last 2 months is when that happened, and because of the war, the numbers fluctuate quite a bit. So I'm not sure whether that really is a trend, but if we look at it today, we see React Native globally pulls away from Flutter, and JavaFX loses a bit. Next, what do developers spend money on when they buy courses at Udemy, which is one of the biggest online training course sites in the world? So people really spending money, I think, is a good indicator, developers in this case. So similar chart, but this time Flutter is in the lead. So Flutter went from 1.3 million to 2.1 million students since March of last year. So React Native this time is the runner-up at 100%, increased as well. Xamarin, there, sitting at 26% of React Native, and then JavaFX, surged a bit, but both have been flat for about a year. So again, takeaway, if you compare versus React Native, we see Flutter pulled away 25% in more than a year. JavaFX added a bit, but has been flat for half a year. Next, Google searches. JavaFX, number 4, peaked in December 2008. Xamarin, number 3, peaked in March 2017. React Native, number 2, peaked in July 2019. And Flutter peaked just a couple of months ago. And so if we look at the numbers per se, then we see Flutter at 99 points, React Native at about half, and then JavaFX, a lot lower. Next one, we're nearly done with the data. Developer popularity, Stack Overflow, everybody's favorite copy and paste source. There, JavaFX number 4 as well. It peaked at the end of 2019. Xamarin peaked at the end of 2018, number 3 as well. React Native peaked at the end of last year, and Flutter peaked just earlier this year. Okay, so if we look at the numbers today, then we see Flutter exactly at twice the number of questions than React Native. And that's surprising because Flutter is a somewhat complete package, so you would expect React Native to have more questions because it gives you more options and gives you more freedom on what components to use. Flutter is batteries included, so but still, Flutter has more questions there. And then JavaFX at 0.13 is kind of at the bottom of the barrel. And then a developer survey, 32,000 developers from a company called Statista, July last year. They do this every year, and we see React Native dropped a bit from 42% in 2019 to 38% last year. Flutter on the rise from 30% to 42%, and then Xamarin dropping like a stone here in these developer surveys. So looking again, summary, React Native lost 4%, Flutter gained 12%, and Xamarin lost 15%. And the last one is analysis from AppFigures, a company that looks at what frameworks are used in apps today. So currently, React Native is used in 24% of the 200% iOS plus Android together. Flutter a bit behind, used a lot less on iOS, 7% versus 11%, and then Xamarin at 8% is the third one. Okay, so if we sum up the popularity, then we see employers really like React Native. UK 3.5 times as many jobs for React Native. Developers, but they prefer Flutter, wins up to 2 times ahead of React Native and pulling away in many cases. I've got a newsletter, a free monthly newsletter, where I do this kind of measurements for JVM languages, frameworks, databases, and web frameworks as well. You can find the link on the talk page. So if you want to sum up, web is the biggest software ecosystem we have. It's got most developers, and React, Angular, Vue are popular frameworks, and that should be our choice. But sometimes we want to do more stuff on native. We want to run native look and feel, native capabilities. Then we can use Flutter, which developers like, or React Native, which employers like, .NET MAUI, and then JavaFX is the least popular choice. Okay, so now on to how Flutter works. Flutter is has a mascot. You can see it here on my t-shirt as well. Mascot is dashed, that's why dashed in from the right, see? Yeah, okay. So now it's a Google project. Of course, everybody's going to be asking the same question. Will Google kill Flutter? Google has the entire web page is dedicated to projects and services killed by Google. It's a hard-earned reputation. Currently, there are 267 projects and services that Google killed. So that's why everybody's going to say, hey, when will Google kill this project? And of course, the answer is we don't know. What's bad is Flutter has competition. There's Angular, another Google project, which actually on its webpage says for web, mobile web, native mobile, and native desktop. So that sounds a lot like Flutter. And then Android has Jetpack Compose, which is Flutter for Android. What's good is that there's external commitment. So Toyota uses Flutter in car infotainment systems, and Canonical rebuilds some Ubuntu apps with Flutter. It's also popular, as we just seen, with developers and also with employers. Less than React Native, but still. Now, Flutter supports different platforms. Since when have they been stable? Mobile has been stable for 3.5 years. The web went stable last year, more than a year ago. On Windows went stable at the beginning of February. And yes, macOS and Linux went stable yesterday. There was a new release, Flutter 3.0, yesterday. Programming language is Dart. If we hear that Java developers, we are pissed because no, not another language, because really what we want to do is we want to use Java, right? Because in the end, we want to write code that looks like that. This is Dart code, okay? Compiles in Dart. It doesn't compile in Java. There's one place where you would see that it doesn't compile. I'm not sure if you spot it, so let me show you. So the list initialization is different in Java. So what you see here is that Google made Dart a language that looks a lot like Java, which also means it looks a lot like C#. So that means you can get these guys into your ecosystem quite nicely because, you give them a language that looks a lot like what they're used to. Now let me switch back to Dart. Although this is Dart, this is not how you would write Dart. This is how you would write Dart, more concise Dart. So you've got simpler variable declaration, simpler methods, here the string templating and a closure. And so if you compare that to Java again, then you see Java does really is the XML of programming languages these days. Very verbose. Okay, so Dart. That was originally built for the browser by Google. It didn't succeed there, and then it got a new life as part of Flutter. I would call it a simplified Java for UI development. So what simplified it about Java? For instance, you have only private and public visibilities. You don't have interfaces, but you can use abstract classes for that, and there's no dependency injection. So it's simplified because in the end you build a UI with it, not a billing system. But it does have things that Flutter doesn't. First of all, it's got sound null safety. So that means you've got less null pointer exception. Both the language and the library can guarantee, null safety. And also has async await, which is concurrency, the same way that you've got it in Swift or in Kotlin, I think uses it well, and TypeScript. So, easier concurrency. Like many UI frameworks, it's single-threaded, but you can create new threads. They're called isolates in Dart. My app just runs on the main thread and is pretty fluent, so I don't think you have to do that. But if you do lots of computation, you can move it off to its own thread. And of course, on a mobile phone, you've got lots of CPU cores, so that's possible there. There's releases every 3 months. Just had one yesterday, then before it was early February. In between major releases, you get minor releases, typically 3, 4, 5. And every release of Flutter also has a Dart release. So both the framework and the language develop in lockstep, even though the language is just finely tuned these days, not a whole lot of changes. The libraries are called plugins. There are about 23,000, maybe 24,000 now of them. Most of them are for mobile, not all of them are for web and desktop. So those are the jars that you would, the jar equivalent that you use in Flutter. Most of these are open source, which is good. And there's a good plugin survival ratio. I've used a bunch of them for a year and a half, and none of them died, which is good. If you ever have a problem with a plugin, there's a feature missing or there's a bug, you can also fork that plugin. Pretty much all of them are on GitHub. And then you can put the URL of that fork directly in your build file. So it's a lot easier to deal with forks there than with Java, because you don't have to create a jar file and put it into a repository or somewhere in your Maven cache. You can just use the URL of the fork project directly in the build file, which is nice. UI elements are called widgets. So let me show them. And what you see here, that's widgets, actually 3 of them, 4. So you see, it's really UI as code. You don't have a UI builder, you don't have a style sheets, you don't have all of that. It's really just code. You write your classes, and everything that the UI needs is in these classes. So here we've got a button with an event handler and another Flutter widget as its contents, an icon, a plus, right? And so if you want to configure stuff here, there's no CSS, there's no property file. You can say, I want you guys to be centered, and you do that by setting a property, right? And so the model that Flutter embraces is actually called declarative programming. You can find more on my talking page. Declarative programming is quite the rage these days. On iOS and macOS, Apple has introduced declarative programming in 2019 called Swift UI. Android followed suit in July last year, Jetpack Compose. And then on Windows, macOS, iOS, and Android, you can use .NET MAUI from Microsoft. Also declarative programming, exactly the same as the other 2 guys. And that's supposed to come out in Q2, so within the next 2 months, right? Until the end of June, 6 weeks left. Okay, widgets. So widgets, as I said, UI is code. No graphical UI builder, no CSS, perfect for backend Java developers, because you just write classes. What do you do with widgets? 2 things. You either configure the built-in ones, or you create your own by including other ones and then building on top of that. The key thing here with the widgets is they don't use native UI elements. So they don't use iOS or Android buttons. They're all emulated. And so that's the same approach that Java used with Swing, right? Everything was emulated, but it works better in Flutter, and I'll show you and tell you about it. Okay, so widgets that give you a look and feel. So that's a collection of components. And there's 3 of them, 3 layers of them in there. First one is you've got a base layer of widgets that you can use everywhere. You've got a row and a column. You've got text and image. And no matter where you are, which platform, you always use the same text widget, or you always use the same image widget. And then there's built-in, there's 2. There's Material UI. Of course, it's Google, right? So Material is the Google design language. and that runs everywhere, and it is the native look and feel on Android. And then they ship as a second one iOS look and feel, which is of course for iOS and iPadOS. And then you can get different look and feels from third parties like macOS and Windows, and you'll actually see that in a second. Talking about seeing that, I got a little treat for you. I created a sample Flutter app for this talk, where I'm going to show you 5 different native look and feels with one code base. Okay, here goes nothing. So first thing I want to show you here is the app. This is 4 copies of the same code running in the mobile app. So this is the iOS simulator. You can see typical iOS UI right here. You can type something in there and you see the label disappearing. But because Flutter just emulates stuff, I built in the capability to switch over to Android. So now the app, even though it's an iOS app, actually looks like it is an Android app, right? So you see here, for instance, the label remains there and the button is different. And this is possible because Flutter just emulates stuff, right? So let's take that away and now go over to the web page. So here the same application running in the web browser with the hamburger menu. And here you see, so that's Material UI. Again, you can type stuff in, and then you see that you've got a Material UI dialog. Now, here if it's running on the web or on desktop, I gave you the option to switch to all 3. So let's just switch over here to Windows. And now the application behaves like a Windows application. Looks different here. That's the Windows Fluent UI. You also have a different dialog, and I could now also switch over to macOS, but instead of doing that, I will just switch over to the macOS implementation. So that's now running the same application as a Mac application. So that looks a little different as well, and it has macOS stuff. And of course, the macOS could also switch over to Windows or web. And then the final one that I just want to briefly touch upon, that's the Android emulator. So here the app runs in an Android emulator, looks and behaves like an Android one, but then I can switch it over and make it look like an iOS one, and now it looks like an iOS one, has an iOS button and iOS dialogs. Okay. So what did we just see? We saw we had 5 different native look and feel, and we could see that we could switch between them because Flutter just emulates this stuff, right? Sample app is on GitHub, and you find it on my talking page. So now how does that switch actually work? Well, I created my own widget. So for the buttons and the dialogues and the text fields and all of that, I created my own widget. And inside the widget, I then said, okay, if I'm on iOS, then I use the iOS look and feel. If I'm on Mac, I use the Mac look and feel. So, pretty straightforward. And you can see it in the source code. When you build a Flutter app, you have to make 3 choices. The first one is state management. That's probably true for all stuff. So global state management. In my app, I use Redux. Flutter ships with something called provider. So, you've got lots of different state management options. The second thing is you have to figure out what kind of look and feel do you want to have. You can either use Material everywhere, you can use native like I did here in my sample and in the app myself, or you can put custom stuff, or you can make a mix of those, right? So that's the second decision. How is your app supposed to look like? And the third one is you have to figure out responsive layout. So you have to adapt to screen sizes and orientation. There's nothing built into Flutter to help you there. There's no grid system, there's no size classes, no nothing. So you have to rely on a third-party plugin to help you. And yes, even on a phone, you have to worry about that stuff. Not just web pages that are supposed to adapt to your screen size for 2 reasons. So here, first you see here phone, iOS, an old iPhone and a Samsung phone. You see the Samsung is probably about twice as big. So right, so you want to show more content on the bigger phones. So you got to take the size into account. And the other thing is your app can probably take the orientation into account. That's my app here, an early version. Switch the orientation, and now in landscape, if you look closely, you see in portrait mode, the cards are on top of each other. In landscape mode, they're right next to each other, right? And with what's built into Flutter, you cannot do that easily. But if you have a grid system or something, then this stuff is easier. Okay, native integration has two aspects. Number one is you can actually make Flutter part of other native apps, which means you can take screens from a Flutter app and put it into an otherwise native iOS and Android app, for instance. The example that Flutter uses, which is it's stable, that works on iOS and Android, is WeChat. It's a popular Chinese app, and they build some screens with Flutter and put it into the native iOS and Android app. Works. It doesn't work on web and Mac. Mac and doesn't work on web and desktop yet, but at least on the web they're working on it, meaning that at some point in time you may be able to take a Flutter app and put screens from that Flutter app into React Angular Vue app. What's more common is the other way around, right? You want to run native code in Flutter. And for the most part, you just use plugins there. So for cameras, pictures, location, this stuff, they are plugins. You use them, you don't touch native code. Your app can also show, your Flutter app can show native screen, and that's the Google Maps plugin uses that. So if you use the Google Maps plugin, it shows you the native Google Maps iOS and Android screens in Flutter. You can also show web pages in Flutter, so you're good there. But sometimes you need to communicate with code. You can do that as well. They're so-called channels, which is asynchronous publish and subscribe between Flutter and the native code. Flutter apps run natively. How do you actually get that capability? Well, Flutter gets that because it relies on platform toolchains, which means that on Android, if you want to build Android, you need Android Studio. If you want to build iOS or macOS applications, you need Xcode on macOS. And if you want to build Windows, then you need Visual Studio, the real Visual Studio, not Visual Studio Code, on Windows. The engine is written mostly in C++ and gets deployed as JavaScript and C++ on the web and C++ everywhere else. The engine is then embedded in your app, and your app is a native ARM library on mobile, JavaScript on the web, C++ on Windows and Linux, and Objective-C on macOS. So it's really natively compiled code. Code build and deploy is important in Flutter because Flutter wants to give you an excellent developer experience. And I think they succeed, and I think that's part of why they're popular with developers, because they ship with good tools. Okay, so IDE, IntelliJ, Android, or Android Studio, and Visual Studio Code are the two supported ones, so popular with Java developers, at least IntelliJ. But they also give you dev tools. You've got an inspector, as you know from web applications maybe. There's a profiler for memory, CPU, and network. And the key thing here is these tools actually work no matter where you launch your Flutter application. So if you just started from the terminal, the tools are available to you because they're written as a Flutter web app. So if you use them in the IDE, they'll just put a frame around the Flutter web application. So DevTools work everywhere, and they're pretty good. What about the code? Well, Flutter gives you a mono repo. So you get one code for all the platforms. If you check out my sample app, 6 different platforms, iOS, Android, macOS, Windows, Linux, and web, all in one Git repo. And you get one folder for your Flutter/Dart code, and then one folder for all the per other platforms. And some of those folders are actually projects. So iOS and macOS are Xcode projects, and the Android folder contains an Android Studio project. And then in there you find these little native shells in the respective language that kick off Flutter. So on iOS you find an app delegate Swift file, and for Android there's a little main activity Kotlin file that kicks off Flutter. Build and deploy is fast, and that's important on mobile especially because it's goddamn slow over there. If you build an iOS or Android app with the native tools, you can easily wait a minute until your app is recompiled and deployed. Flutter Dart has a virtual machine during development, so in that sense it's like raw VM, virtual machine during development, and native compiled code for production. And that gives you two things. Number one is a hot restart, so your entire application gets restarted in about 3 seconds. But the coolest thing is hot reload, where between pressing save and seeing your application updated on the iPhone or the emulator within just 1 second. And it does work, and there's a video of it on my talk page. So now, given all that, let's look at the Flutter platform check on mobile. I give Flutter thumbs up. Why? Because you really do get 2 apps for the price of 1. You have access to all the native functionality. You've got native look and feel. You've got access to all the native functionality, and your build and deploy is even faster than with the native SDKs. Web, thumbs down, as I said at the beginning. Why? For the UI toolkit, you only get Material UI. On the web, you've got a gazillion different, design system, components library, UI skins, the world's your oyster. On Flutter, they just give you Material UI, and you're supposed to customize that. Flutter on the web also doesn't have access to the libraries, which would be the JavaScript libraries. You can't get to them. You can only use your Flutter plugins, which means that you just have a tiny amount of libraries, a subset of those 23,000 plugins versus, literally millions of JavaScript library. That's why I think thumbs down. On the desktop, also thumbs down, because why do you want to build a desktop application? Most users are fine with a web application, right? And the web browser on desktop is much less restricted. Even Safari has push notifications there, right? So that's why probably most people don't need a desktop application. If you do, desktop just went stable. Windows in early February and macOS and Linux just yesterday. So there's probably, some trouble there. On the plus side, you do actually get access to native libraries because you can call into C++ code. And so that's why you can probably use all Windows, macOS features. Unfortunately, the look and feel, the widget sets are incomplete. So for instance, on macOS, the look and feel doesn't include a dropdown. And it's a lot of work to keep the look and feel, all the animations, all the widgets, up to date and complete and tracking the platform. So that's why, it could be that it just doesn't exactly look like like macOS or Windows there. Okay, so let's summarize. Dart is the programming language. It's a simplified Java tuned for UI development. Plugins are the libraries. Widgets are the UI elements. They're emulated. Widget sets give us the look and feel. We get Material in iOS with Flutter. Flutter gives us access to all native functionality on mobile. It runs natively because it compiles with the platform toolchains. It gives us great dev tools, a mono repo, and faster build and deploy on mobile than the native guys do. And in the platform check, it really shines on mobile, not so much on web and desktop. Okay, so that's how Flutter works. Now briefly to my Flutter experiences. I'm a co-founder of a tiny startup. We are a B2B SaaS company for UK companies that employ cat sitters. Yes, you heard right. And our business proposition is that our apps remove friction and save time so that people always know where they have to go and what to do there. And I wasn't kidding when I said it's a tiny startup because I wrote all the code. I do write all the code. So what do we've got here? We've got just a very typical architecture, a Spring Boot application with a Postgres database as the backend. We also use Firebase, which is Google's backend as a service for authentication and storing files. There's two front ends. The managers use a Angular application to schedule visits and manage customers. And then the cat sitters go out into the world and they use a mobile app on Flutter, built with Flutter. And both of these use the same JSON REST API into my Spring Boot application. So why did I pick Flutter? First one is I didn't want to have any restriction. I wanted to store lots of data because the app's supposed to work offline and there's pictures and there's videos. I wanted to have push notification and I couldn't get that with web technologies. I also wanted the app to be as fast as possible because our users pay us to remove friction to save time. And I felt the best way to do that was to be close to the metal and have a native UI. And finally, because Flutter is a lot similar to Dart, because Flutter uses Dart and Dart is like Java that I know and love, and it's got a pretty good build and deploy speed, I felt I was quite productive there, more productive than building a web application, which I did test, and you can find that on the talk page as well. So what you find on the talk page here is details on, yes, Flutter works and native UI works, and you find screenshots and you can take a look at it. I also tell you about Firebase from Google, that backend as a service, tell you how I use the mobile power, the power of these mobile devices, how I try to keep my UI correct with the one source of UI truth. I'll try to be consistent between my web app and the mobile app, and then even mobile apps with Flutter are just software, so basic principles still apply. You can find that on the talk page. Okay, so that sums up my Flutter experiences, and now we come to the difficult part, that is when to use which mobile native cross-platform framework. I restrict this to mobile, so just iOS and Android. But before we do that, let's just sum up what we heard so far. Why do we need cross-platform front ends? Cross-platform front ends. We need them because they're cheaper and they are good enough for what we want to do. How can we build them? Well, we should use web. It's the biggest software ecosystem we ever had. Lots of developers, React, Angular, Vue, in that order are the most popular ones. Sometimes we need to go native, which means running native, having native look and feel, and access to native functionality, especially on mobile. Flutter, preferred by developers. React Native, preferred by employers. .NET MAUI and JavaFX as additional options. How does Flutter work? Dart is simpler Java. Plugins are our libraries. Widgets are the emulated UI elements. Widget sets its look and feel. We've got native access to native functionality on mobile. Runs as a native because it uses the platform toolchain. It faster build and deploy on mobile than the native guys, and the best platform for Flutter is mobile. My Flutter experiences, I told you about my business case, unlimited storage, push notifications, native look and feel, being productive, and then the other things, you find them on my talk page. Now, let's compare Flutter versus the world, and that is actually the world just has two pieces here. Number one is we want to compare it against the arch enemy, React Native. So React Native uses JavaScript, Flutter uses Dart. That's why React Native is a bit slower, because it interprets JavaScript at runtime, whereas Flutter compiles down to machine code on mobile, and so that's why it's faster. Now, React Native uses the native UI elements, Flutter emulates them. If you build a web and mobile application at the same time, it's two projects, React and React Native, whereas with Flutter it's one project. And there is no official desktop support in React Native. There's forks, so you can build Mac and Windows there, but it's unofficial, whereas with Flutter there is official support. I also want to look at Flutter versus JavaFX popularity. We see in Flutter is anywhere from 11 to 20 times as popular as JavaFX. Students lower, 11 times as many students. Questions on Stack Overflow, 22 times as much. Let's compare JavaFX versus Flutter. First difference, JavaFX uses Java, yay. Flutter uses Dart, which is not Java, but kind of close. With JavaFX, you use a UI builder, whereas Flutter, you do the modern thing, UI as a code, declarative programming. Again, details on my talk page. JavaFX does not give you a native look and feel. Flutter does. JavaFX does not give you access to all native functionality. Flutter does. In JavaFX, web is very new. And so still immature, and in Flutter, the desktop support is still a bit immature. Okay, so now we're finally ready to answer this question. When should we use which mobile native cross-platform framework? Here's my recommendation. I base it on the developer experience. What's the background of the developers working on that? If you've got a bunch of web developers, use React Native. If you've got .NET guys, use .NET MAUI. If you have Java developers and you've got libraries, Java libraries, JARs, that you can only find in Java and nowhere else, legacy libraries, well, then you have to use JavaFX. It's the only way to run on mobile then, right? And for everybody else, I would recommend Flutter. So that brings us back to the big question from the very beginning. Can we build mobile web and desktop frontends with Flutter in one code base? Yes, we can. And you've seen that. But we shouldn't. Right? Flutter only recommended on mobile, 2 apps for the price of 1, better than native in build. On the web, we only have Material UI, very few libraries. On the desktop, probably shouldn't build a desktop application, and the desktop platform in Flutter is just barely stable. Java server faces, no single page application. We can't build single page application with it. No new features for a couple of years, and very unpopular. JavaFX, we just saw it, no UI builder, no native look and feel, no full access to native features, and very unpopular. Okay, so that means I'm nearly done with my presentation, but my talk doesn't stop when I stop talking. Yay! Sometimes I thought I should have done a career in marketing, because that's my slogan. So, I told you this, you're going to see this slide again at the very end. So if you go there, you find my slides, and my slides, the PDF version has more words than I used here. You find additional information, web framework popularity, details about my experiences. You find a link to the app that I showed you, links to getting started with Flutter, and you can subscribe to my newsletter if you want to see my popularity measurements for other stuff as well. Okay, so do you guys have any questions? Not everybody at once, please. Okay, there, gentleman in the front, please.
So just a you have in your architecture, you had a Spring Boot app. Why'd you decide to go with that, like a Spring Boot app in the database there versus like just keeping it all on Google and using like Cloud Functions or something?
Okay, so the question was, why did I go with Spring Boot as my backend and didn't use something like Firebase for everything? The reason is I know Spring Boot, I want to use Java, and I want to keep both my costs down, because if you host it in the cloud, then you're going to pay, and it's for me cheaper there. And finally, the last reason is I wanted to have control over my data, because that's also part of our solution. We say, hey, we keep your data secure because the application is about people entering people's home. We literally, if you can read that, know how to get into somebody's home. Here are the keys, here's the door code, here's the alarm code, right? So we want to keep that information safe, and we think we can have a better story if we've got the data completely under control versus, shipping it to Google. I don't say that, Google takes away the data, but we talk to people and we think it's easier for them to understand the data stays with us. Google doesn't have data, because sometimes people get emotional about who gets their data in the cloud. Okay, any other questions? There we go, gentleman here. Well, this gentleman first, then you, and I'll repeat the question. No mic needed.
I mostly agree with all the comparisons. I really like Flutter. I think it's a really good choice for developing for both platform at once. And just slightly disagree that React Native doesn't have support for desktop. I think many people, it's a very popular choice to build JavaScript application for desktop using things like Electron, and they have maybe limited, but some of the native features like push notifications and probably something else.
Okay, so the comment was, React Native doesn't have official desktop support, but you can build it with stuff like Electron or so. Yeah, that is completely correct, but then you don't have a single code base anymore, right? Because then you have your mobile app with React Native and then something else on the desktop. And to a certain degree, the idea is, hey, I've got a mobile app built with Flutter, and if I started there, then maybe there's a business case to say, hey, okay, if I already have that and I don't have a web application or a desktop application, then it makes it easier to build. And whether you should do that or not is a different. But at least it gives you the option to say, hey, I take my mobile app, and then move it to the web or to the desktop. Whereas the web is the most common case, right? If you have a mobile app and a web, you're golden, right? Nobody really cares about desktop except for Slack people and Mac and iOS. Okay, gentleman in the back.
Thank you. Sorry about that. I got handed a mic, by the way. This isn't mine. The emulation of UI elements is fantastic, but presumably if the OS upgrades, for example, like iOS upgrades, and the UI changes slightly, it has the downside of looking slightly outdated, presumably, until Flutter updates their emulations that you then use, which is fine. That was just a comment more than a question. My question was, in terms of using the native aspects of the operating systems that you're doing, the Android and iOS, presumably there's OS-specific code that you have to write to use each, because the customizations and the options that go into those are going to be very specific to the platform quite often. Presumably there exists in all of these tools that are centralized at one code base for multiple platforms. Inevitably, at some point, you're going to have to write code that interacts with the native APIs. Is that something that can spiral out of control, or is there like a standardization way of doing that in Flutter, or is it mostly the UI that benefits rather than when you get to deal with the native stuff? does it always have the same problem?
Okay, so 2 questions there. The first one was about the emulated stuff. Somebody needs to update the look and feel. That's always a given with material, right? Because it's Google stuff. So whenever Google changes material, they update stuff in Flutter. In iOS, there hasn't been a whole lot of change. There was one new UI control, the slider segment control in iOS 13. It took them, I don't know, 4 or 5 months until it actually showed up in Flutter. With the macOS and Windows look and feel widget sets, they're open source, so no idea what that's going to be. Coming back to the native code, you do have the native code in your application. So if you open up, you've got a, let's take a look at iOS, for instance. You've got a, the Swift file there, and you put your code in there, and it is an Xcode project, and to Xcode it looks exactly like a native project. You can use it and run it in Xcode, and it starts up everything. So you can put that code into that file, which is part of your Flutter project, and it works exactly as it would. And for instance, for Google Maps, you need to do that. Google Maps needs some native code, both in iOS and Android. You put it into those files that are part of your project, and it works. Okay. Time's up. If you have any more questions, I'm still hanging around here tomorrow as well. So come up and talk to me. I'm the Flutter guy. Thank you.